that energy low turns out to be equivalent to the point of equilibrium. So you have a dynamic equilibrium, and dynamic equilibria represent energy lows. And so what you have in living things are many, many chemical reactions and physical processes that have been perturbed away from equilibrium. Anytime you perturb something away from equilibrium, it requires energy to do that. And the reason it requires energy is because the equilibrium point itself represents the energy low. So any change from equilibrium requires an input of energy. And this is showing this idea yet again. So the equilibrium situation is the low energy point. And in order to pull things away from equilibrium, you have to put energy into the system. Because of something known as the second law of thermodynamics, whenever you are doing any process, the process is inefficient. And therefore, you always are going to lose energy in the course of changing one thing into another thing. And that energy is often seen as waste heat. But basically, if you're perturbing something away from equilibrium, you're going to have to put energy into the system. And at the same time, if you have something that's perturbed away from equilibrium, there's at least some potential by allowing it to move back towards equilibrium to get energy back out of it. You're never going to get all the energy out of something that you put in because of this second law of thermodynamics thing. There's always going to be energy lost, and typically it'll be lost as waste heat. But if something is at equilibrium, it's at an energy low. To pull it away from equilibrium, you have to put energy into the system. And basically, living things exist perturbed away from equilibrium, and they need an ongoing supply of energy in order to keep away from equilibrium.